All right, here we go. This is the homework for tonight. Number one we did in class. It looks like this. We're doing just this page, the page that says multi-step equations, variables on both sides. What we have here are equations with variable terms on both sides. So I'm going to start with number 2. Number 2 says 20k plus 5 equals 5k plus 65. We have a variable term on the left, a variable term on the right. The equal sign is really breaking up the left-hand side of the equation from the right-hand side of the equation. We talked about in class how the variables need to be on one side of the equation and the constants need to be on the other side of the equation. We must use both sides of the equation. So what I'm going to recommend that you do is to get rid of the 5k and to move it. This gets rid of it. 5k minus 5k. We talked about like terms and adding and subtracting. If you have 5k and you subtract 5k, what that does is eliminates it on the right-hand side. It then jumps over here, and I line it up right underneath the like term of 20k. 20k minus 5k is 15k. That's done. Bring down the plus 5 and bring down the 65, which is positive. I'm not going to put a plus sign in front. It's positive. Now, I've moved my variable terms left. I must now move my constant right. We talked about in class how we cannot move 65 left because then I would have only one side and I would not have an equation. I'd have nothing on my right-hand side here. So what I have to do is move 65, or rather I have to move 5 over to the 65 like so. So plus 5 minus 5, inverse operations, cancel out. So the moving process is all about adding and subtracting. It's not till the end do you think about multiplying or dividing to solve. So we're now at the end. A lot of people won't even do any multiplication or division. They'll just do mental math. 15 times what is 60? And the answer is 4. But what you can do, the inverse operation of multiplication here is division. So I'm going to divide by 15. You do not divide by 15k. You leave k unharmed, unscathed. You leave it alone. K needs to stay here. So it'll be k by itself. 15 over 15 is 1. 1k is just k, right? If you divide by 15 there, you must divide by 15 here. It's this balancing operation. What is done over here must be done over here. 60 divided by 15 is 4, and your first question here for homework is done. I put on top also something we talked about in class, the Don't Call Me After Midnight acronym. This will provide you with some steps. So if you're just totally lost, confused, don't know where to start, don't have any clue where to begin by distribution, by doing the distributive property. Now in this first question, there wasn't any distributive property, so then you go to the next thing, which is the C, or the call. Combine like terms. This means if you have like terms on one side, you need to combine them. These are not like terms, I can't do anything there. These are not like terms, I can't do anything there. So we're already on to the move part, which is what I did in this question here. I just moved terms to separate sides. I moved my variables left, I moved my constants right by adding and subtracting the terms. And the after midnight part, I'm not sure what that, I can't remember what that stands for anymore, but it helps to memorize, at least don't call me. The after midnight, I think it's add, subtract, I don't know. Midnight is multiply or divide, so there's no more adding, subtracting, but multiply, divide at the end. But you get the point. The purpose is to help you remember what to do. Distribute, then combine like terms on one side, then move. You'll see more. So distribute doesn't apply. Combine your like terms. Now, this side, there's nothing to combine. This side, you can't add 20 plus y. So in terms of combining your like terms on separate sides, there's nothing to do there. What you need to do, though, is you have to move terms that are like to one side. So the move part up here, the move, is you have like terms. The problem is this negative 9y and this positive y are on separate sides of the equation. Draw the line through the equal sign if that helps you. Now I'm going to move the y over there because I'm looking to put my y's to one side. I cannot bring my 9y over because then I'd have nothing on this side right here. It'd be empty. An equation must utilize both sides. So what I'm going to do is subtract y, it goes away. Y minus y is 0. Subtract y here, or subtract 1y. That's a 1y. Negative 9 minus 1 is negative 10. y. Equal sign comes down, 20 comes down. There's nothing more to do but to solve this thing. When you have gotten to the point of having one step left, or a one-step equation, that means it's time to solve. So to solve for y here, you're going to divide by the same exact number in front of the y. That makes 1. What you do here must be done there. So y is equal to -2. Also a good idea, take your answer. Plug it in the original equation. -9 times -2 is 18. 20 rather, plus -2 is 18. It should make the equation true when you plug it back in. And it does. If it doesn't, you messed up. And then you got to go back to the drawing board. Number 4, we have a couple of fractions mixed in there. We have, again, variable term, constant. Variable term, constant. No distribution, and you can't combine like terms here. No distribution, and you can't combine like terms here. So you're down to now moving to combine like terms. That is moving sides, moving terms across this line. So I'm going to take the 3x, goodbye. Now it's over here. I balanced it. What it's done here must be done here. 2x -5/4. My x's went left. That means my constant of -1/4 must go right, but it's not going to be -1/4. It's going to be add 1/4. That'll cancel it. Add 1/4. So I have 2x, -5 plus 1 is a common denominator of 4, so that stays the same as fourths. -5 plus 1 is -4. Let's make that a better looking question. 2x equals -4/4 is -1. 2 times what is -1? If you can't figure that out, then go ahead and just do your step of dividing by 2 and dividing by 2 so that x is equal to -1/2. There you have it. Let's keep on going. Not going to go beyond 15 minutes here. I don't want to take too much time here. So whatever I get to, I get to. I'm going to just keep pushing. Similar question to number 3. I feel like this is it. Now with this one, here it is. With this one, I have variables on both sides. I don't have a constant on both sides. So I'm kind of being forced to move this 16k over here. I can't subtract 13k, although it's tempting to subtract it and bring it over. That would leave me with nothing here, which I no longer have an equation. So what I'm going to do here, so I can utilize both sides of the equation, I'm going to subtract 16k, subtract 16k. -15 comes down, -3k comes down. You're solving for k, which means gets k by itself. So you're going to divide by the number in front of k, or the coefficient of k. -3 divided by -3 is 1. 1k is just k. What is done to the right must be done to the left. A negative divided by a negative is a positive, so we're going to say a positive 5, and 5 equals k means k equals 5. Now there's another option here I'm going to show you real quick, because some people will do this, and I'm not opposed to being creative. So I was saying before how it was forcing you, this question was kind of forcing you to go a certain direction. Meaning, I subtract 16k to join the k over there. Well, let's just say we subtract 13k, right? And subtract 13k, right underneath the 16k, right? So like terms becomes 3k minus 15. Now I overloaded my left-hand side of my equation. I have nothing here. Nothing here means I have 0. Okay, well, I can't solve this until this -15 gets over here. So you could do this. You might even like this better. So 3k equals 15. Therefore, k equals, there it is, 5, right? So I got a little creative there. I ended up moving everything left, but then I decided, let me move the 15 back to the right so I don't ruin my equation. But you can't solve it when it's just over here. You'll end up being off by negative or positive, so it's an option. Number 6, variables on both sides, constants on both sides. I see a good opportunity to add x. I'd rather have to deal with a positive 2x by adding x. So I'm going to add x and add x. x plus x is 2x. I notice that some of you don't use your lines on your paper, and even as messy as I am, I still not want to deviate from not using my lines, so stay in between the lines. Use the lines on your paper. I move my variables left, I must move my constants right, so add 7, it sends it over here, balancing my equation, plus 7 plus 7. What you do here must be done here. You can't do plus minus. If you add 7, you must add 7. You probably could do this mentally. 2 times what is 20? 2 times 10. If you prefer the last step, there it is. I've got some decimal work here. I'm going to put my variables to one side again. I see an opportunity to move this over here. I'd rather do that. Again, make the line if you have to. The equal sign should break up your left and your right hand side. Minus 4.5 m cancels. Minus 4.5 m. Let's bring back some 6th grade memories. 6th grade memories is 6.0 minus 4.5. You must line the decimals up. Borrow from this. Make that a 10. Bring the decimal directly down. 5 minus 4 is 1. So we're talking about 1.5 m. I brought my variables to the right. 18 is by itself over here. I have a plus 12 over here. You must send the 12 over to the left by subtracting. Again, the moving is just adding or subtracting. You don't need to worry about dividing or multiplying until the very end, which is where we're at right now. Last step, 1.5 times what makes 6? Some of you could do it mentally and get 4. Others of us may want to divide 1.5, divide by 1.5. 1.5 goes into 6. 1.5 goes into 6 4 times. Last page for me, 8, 9, and 10. My homework is done. I got about a little under 3 minutes. Here I go. This one actually requires distribution. So here we go. Our first distribute. Distribute, combine like terms. Let's distribute 3x. 3 times 7. Don't forget the second part of the distribution. 3 times all of this, not just the x, but 3 times 7 as well. 6x plus 12. And I'm back to what we were looking at before. Variables on both sides, constants on both sides. I'd rather bring the 3x over here. By minus 3x, it's a little nicer. I'd rather not have negatives unless I have to have them. That becomes 3x, subtracting. 21 comes down. So I brought my variables to the right. 12 must go left. Inverse operation, plus minus, it cancels. All right, it leaves us with 9 equals 3x. Simplest, x equals 3, right? Next one. No distribution in this one, just like the other ones. We're going to move our variables to one side. I like the fact of taking 5x going left with the 5x. For this one, let's send the 5x left. 5x left. I don't like to make my videos longer than 15 minutes, so I'm putting a cap at 15 minutes here. That brought my variables left. That got me 3x. I'm going to add 6, add 6. 3x equals 18, x equals 6. Last but not least, here we go. Distribute first on the left, negative 2w, and negative 2 times 10. You can't even see it. Sorry about that. Negative 2 times w is negative 2w, and negative 2 times 10 is negative 20. Alrighty. I like this going right. I prefer 2w sent right. Making 8w. My variables went right. Don't lose that minus sign. That minus sign belongs to the 20. Subtract 12. Send that left. Negative 32 equals 8w. Divide by 8 on both sides. This is the final step. So w equals negative 4, or negative 4 equals w. That's it. That's multi-step equations with variables on both sides. We'll do the next page tomorrow, a little more intense, with the multi-step equations with different solutions. Adios. See you tomorrow. Bye-bye.